For question 4, they ask you questions about the domain and the range of this piecewise function, and then you need to select the correct answer. So to look at the domain and range, you're going to have to sketch it eventually. But now, as you can see here, there are absolute value signs here. Now we want to get rid of those. So using your theorems, we know that when x is smaller or equal to something, it is between that. So it's minus 1, x, and 1. Okay? And then for the other part, when the absolute value of x is larger than 1, we know that it has to be, x has to be greater than 1, or x is smaller than minus 1. Now you can also do it graphically, which I did do here, but I suggest that you memorize your theorems because it's a lot faster than using the graphical method. Now we can rewrite these things down here. So we rewrite the piecewise function. So we have minus 1 and 1 constrain x there. So x is between minus 1 and 1. And we have that x must be smaller than minus 1 or greater than 1. So our interesting points, our boundaries, are going to be minus 1 and 1, which is these light blue lines that I drew. So let's do the easiest function first, which is the first one. Y is equal to 2 when x is between minus 1 and 1, which is here. So there's 1. And it's a closed dot because we are saying they are included there and there. Okay, greater or equal to, and smaller or equal to. So it's a closed dot there, and it is a closed dot here. Okay, and then y is equal to 2 between those 2 points. So we have this function there. Now we go on to the next one. So now I've drawn it very lightly in orange here. That would be the general shape, and it would just carry on there. But we only draw that function. Instead of drawing the whole thing from minus infinity to infinity, we're only drawing the part that is smaller than minus 1 or greater than 1. Now if you're uncertain about the shape, substitute values in. So that's what I'm just going to do briefly. So at minus 1, I'm going to say 1 minus minus 1, which will give me 2. Now, in this case, it should have been an open circle, but because we've already included it, this minus 1 and 2 point, using the first function, it will stay a closed dot. Then for the next part, now substitute another value in. 1 minus minus 2, which is down here. Then you can say 1 minus minus 2 is 3. So then it'll go up to 3. So it'll carry on like that. Draw an arrow because that shows that you know it's going on into infinity, which it is. It's going on to minus infinity over there. Now on the other side, you do the same thing. Now our boundary value is 1. So we substitute 1 in there. Now 1 minus 1 is 0. So it's here. Now we're going to do it as an open dot because it is not greater or equal to, it is just greater than. And again, when you're not sure about the shape, you substitute in a value. So let's take 2. 1 minus 2 is minus 1. So there's another point there. So then I'm going to connect them. And this one will also carry on into infinity. So be sure to draw an arrow. So now you have your graph. For the domain, you can see that from minus infinity to infinity, there is always some kind of x value. Even here, where the graph isn't connected, there is still an x value everywhere. So our domain will be written as x is an element of minus infinity to infinity. And remember that the infinities are always excluded, so it's a round bracket. Then for the range, let's start from the bottom. So from minus infinity, it carries on but stops at 0. So we have y is an element of minus infinity to 0, and it is a round bracket because of 0 being excluded. But now we'll carry on. There's another part. So the range carries on then from 2, including 2, up to infinity. So then we have square bracket 2 to infinity. Then you select the correct answer, which in this case would be B.